Bismillahirrahmanirrahim. Welcome to my channel of Applied Thermodynamics by McConkey with Dr. Abid Hussain. In this lecture, we solve problem 1.4 from McConkey. So, question is 1 kilogram of a fluid expands reversibly according to a linear law from 4.2 bar to 1.4 bar. The initial and final volume are 0.004 cubic meter and 0.02 cubic meter. This is the first process. In this process according to a linear law. Generally, linear law is y is equal to mx plus c, and P1 and P2 are given, and expansion pressure is decreases from 4.2 bar to 1.4 bar, and expansion volume is increases from 0.004 cubic meter to 0.02 cubic meter. Second process, the fluid is then cooled reversibly at constant pressure. Pressure is constant, it means that P2 is equal to P3, and cooling reversibly. And finally, compressed reversibly according to a law PV is equal to constant back to the initial condition of 4.2 bar. And this process this process is isothermal. PV is equal to constant, and the cycle is completed back to the initial condition, mean that cycle is completed at 4.2 bar and 0.004 cubic meter. There are three processes, one complete thermodynamic cycle, and calculate the work done in each process and the net work of the cycle. Sketch the process on a PV diagram. तो सबसे पहले हम डेटा लिखते हैं. First process is according to linear law. Linear law is generally is y is equal to mx plus c. In our case, PV diagram, so P is on y axis, m is slope, m is not mass, m is slope. On x axis we plot volume, total volume in this case. C is intercept on y axis. So P1 is given and the problem is 4.2 bar. 4.2 bar. Expansion pressure is decreases to 1.4 bar. V1 is equal to 0.004 cubic meter, and V2 is 0.02 cubic meter. This is first process. Second process is cooling at constant pressure. It means that pressure is constant. Pressure constant means that P2 is equal to P3. P2 is equal to P3 is equal to 1.4 bar. Third process is isothermal. PV is equal to constant. Third process is isothermal. PV is equal to constant. So, and the cycle is completed on third process. It means that the P1 after P3 this regain to their original pressure and volume. P1 is equal to 4.2 bar initial pressure, and initial volume is 0.004 cubic meter. Now, in given data, P1, P2 and P3 all are given. V1 and V2 are given, but V3 are not given. So from this process, with the help of this process, we can find V3. As we know that PV is equal to C, so this implies that P1 V1 is equal to P3. This is third process, so P1 V1 is equal to P3 V3. So V3 is equal to P1 V1 divided by P3. which putting values P1 is equal to 4.2 bar, V1 is equal to 0.004 cubic meter, and P3 is equal to P2 will be equal to P3 is equal to 1.4 bar. If we calculate this value, so the value of V3 will be from calculation, the value of V3 will be 0.012 cubic meter. V3 will be equal to 0.012 cubic meter. Now we draw PV diagram. So initial pressure is 4.2 bar, 4.2 bar. After expansion, pressure is decreased to 1.4 bar. P1, this is pressure in bar, this is volume, total volume in cubic meter. Initial volume is 0.004 cubic meter, and V2 in the first process volume is increased to 0.02 cubic meter. So this is first one, this is first one, and this is second one. So from this is point 1, this is point 2, and linear line equation, so this will be straight line, so this will be straight line. Now it is cooled at constant pressure to V3. V3 is 0.012 greater than 0.004 and less than 0.02. It means that V3 is between V1 and V2. V3 is a 0.012 cubic meter. This is V1, this is V2, and this is V3. And this is P1, and this process is constant pressure process, so P2 will be equal to P3. So now the second process is cooling at constant pressure, straight horizontal line. And third process is expansion back to the initial condition according to PV is equal to C. So this is expansion according to PV isothermal curve. So this process is P is equal to mv plus C. This is constant pressure process, and this process is PV is equal to C, isothermal process. So this is the PV diagram. Now we find work done from 1 to 2. Now we find for work done from 1 to 2. First process is according to PV, according to P is equal to mv plus C, and m and C, m is slope, C is intercept. These two are constant and these are unknown. So first we find from this equation slope and intercepts. As we know that P is equal to mv plus C, so P1 is equal to mv1 plus C, and P2 is equal to mv2 plus C. Putting values in these two equations, so P1 is 4.2 bar, and 1 bar is equal to 10 power 5 Newton per square meter. is equal to m is unknown and V1 is equal to 0.004 cubic meter plus C. This is equation number first. Similarly, P2 is 1.4 bar and 1 bar is equal to 10 power 5 Newton per square meter is equal to m 0.02 cubic meter plus C, and subtract equation second from first. Equation first minus equation second. So subtract this, change the sign. So C will be cancelled with C. 4.2 minus 1.4 is equal to 2.8 bar. 2.8. 12 minus 4 is equal to 8 and 3 minus 1 is equal to 2. Multiply by 10 power 5 Newton per square meter is equal to m 0.004 minus 0.02 is equal to, subtract 0.02 from 0.004. So this is equal to minus 0.016 minus 0.016 cubic meter. Now divide both sides by minus 0.016 cubic meter. So m slope is equal to minus 175 multiply by 10 power 5 Newton per meter pipe. Put this value in equation first to find C. Put in equation number first to find C. So equation first has 4.2 multiply by 10 power 5 Newton per square meter is equal to, the value of m is, this is equation number first, the value of m is minus 175 multiply by 10 power 5 Newton per meter 5 multiply by 0.004 cubic meter plus C. So simplify this equation. So C is equal to 4.9 multiply by 10 power 5 Newton per square meter. Now we can easily find work done from 1 to 2. W from 1 to 2 is equal to W from 1 to 2 is equal to minus integral of 1 to 2 PdV and minus lower limit is V1, upper limit is V2. P in first process is equal to mv plus C, where m is slope dV. So W from 1 to 2 is equal to minus integral of V1 to V2 mv dV and minus integral of V1 to V2, m is constant, so we write m here, and C is constant, so minus C integral of V1 to V2 dV. So W from 1 to 2 is equal to minus m integration of V is equal to V square divided by 2, lower limit is V1, upper limit is V2, minus C integral of dV is equal to V, lower limit is V1, upper limit is V2. So W from 1 to 2 is equal to minus m by 2 Now apply limits. V2 square minus V1 square minus C, upper limit is V2 and lower limit is V1. So now putting values, W from 1 to 2 is equal to minus into minus 175 multiplied by 10 power 5 divided by 2. V2 square, the value of V2 is 0.02 square minus V1 is equal to 0.004 square divided minus C. The value of C is 4.9 multiplied by 10 power 5. 4.9 multiplied by 10 power 5. V2 minus V1, 0.02 minus 0.004. Now W from 1 to 2 is equal to minus multiplication is equal to plus, and 175 divided by 2 is equal to 87.5 multiplied by 10 power 5. The unit of M is Newton per meter 5, and take square of this and square of this, then subtract from this value. The answer will be equal to 0.0000384 meter power 6 minus 4.9 multiplied by 10 power 5. Value of C is Newton per square meter, and 0.02 minus 0.004 is equal to minus 0.016 plus 0.016 cubic meter. Now simplify these values. The final answer will be minus 4480 Newton meter. Negative sign means that work is done by the system. Now we found work done from 2 to 3. 2 to 3 process is constant pressure process. The formula for work done is minus integral of 2 to 3 from 2 to 3 PdV. So W from 2 to 3 is equal to minus P is constant, from lower limit is V2, upper limit is V3 dV. So W from 2 to 3 is equal to minus P, integral of dV is equal to V. Lower limit is V2, upper limit is V3, which is equal to minus P. Apply limits, V3 minus V2. So W from 2 to 3 is equal to minus P. This is minus P2 or P3 because P2 and P3 are equal. Minus 1.4 bar, 1.4 multiplied by 10 power 5 Newton per square meter. V3 is 0.012 cubic meter minus V2 is 0.02 cubic meter. So simplify this value. This calculation is too much easy. So the answer from 2 to 3 is a W from 2 to 3 is equal to 1120 Newton meter. Answer is plus. Plus sign mean that work is done on the system. Now we find work done from 3 to 1. Work done from 3 to 1. So third process is according to PV is equal to C. First we find C. So as we know that PV is equal to C, so P1 V1 is equal to C. So this implies that C is equal to P1 is 4.2 bar mean 4.2 multiplied by 10 power 5 Newton per square meter, and V1 is 0.004 cubic meter. So C will be equal to 0.0168 multiplied by 10 power 5 Newton meter. This is the value of C. Now formula is work done from 3 to 1 is equal to minus integral of 3 to 1 PdV. So which is equal to, as PV is equal to C, so P is equal to C by V. So put here C by V. Minus integral of lower limit is V3, upper limit is V1, and put C by V here. So W from 3 to 1 is equal to minus C is constant, and integration of 1 over V is natural log of V. Lower limit is V3 and upper limit is V1. So W from 3 to 1 is equal to minus C. Apply limits, natural log of V1 minus natural log of V3. So W from 3 to 1 is equal to minus C. According to law of logarithm, natural log of V1 minus natural log of V3 is equal to natural log of V1 divided by V3. Now putting values, so W from 3 to 1 is equal to minus the value of C is 0.0168 multiplied by 10 power 5 Newton meter, and natural log of V1, the value of V1 is 0.004 cubic meter, and the value of V3 is 0.012 cubic meter. So if we calculate this value, so final answer will be equal to 1845 Newton meter. Now net work is required, so net work done is equal to work done from 1 to 2 plus work done from 2 to 3 plus work done from 3 to 1. So net work done is equal to work done from 1 to 2 is minus 4480 Newton meter, plus work done from 2 to 3 is 1120 Newton meter, plus work done from 3 to 1 is 1445 Newton meter. So net work is equal to minus 1515 Newton meter. Negative sign means that work done by the system is equal to 1515 Newton meter, and this is the final answer. And for more videos, please subscribe my YouTube channel. Thank you.